All right. So, good day, everyone. My name is Akunle Kandane, popularly addressed as Global Pentagorians. I'm a student of Federal University of Technology, Accra, from Department of Industrial Mathematics. So, today we are doing the Global Maths Group Rates broadcast, 7th episode, under Maths with Purpose. So, the topic for today is the mathematics of thinking, building stronger classroom through reason and evidence. And our guest speaker is here for us from US, Arizona. So our guest speaker, you can introduce yourselves.
Yes, my name is Jeff Ringer. I am an instructional coach at a middle school. This is my 9th year in education. I have taught ELA, science, social studies, and mathematics.
Wow, that's great. So today is going to be amazing. It's going to be like an interactive question. This question, guest speaker explain to us how mathematics is working, the mathematics of thinking. So the first question we have here is, what inspired you to become an instructional coach?
So I kind of got into this in a non-traditional path. Teaching was not exactly on my radar. It wasn't something that I wanted to do when I was young, but I had always been passionate about learning and thinking, and I would study things like classical education, economics, epistemology, sociology, apologetics, and I always had this interest of trying to help people and help people who've been disenfranchised. And I would be really interested in, like, how does knowledge influence the way people behave? And so that kind of led me to working with a group of refugees in the Phoenix area. And during that time, I had a spinal injury while I was in the military. And that kind of changed my career path. And one of the people groups, they would call me Thro, which means teacher in their language. And so as I was kind of thinking about what could I do with my life, it's like I already have people coming to me, bringing their children to get tutoring, because the parents were from another country and they didn't speak English, and so they didn't really know how to help their children. And so I was like, well, if I'm already doing this on my own time, I might as well do this like as a profession. And then as I got into teaching, like I realized that if I really want to have an impact on people's lives and get education where the people are thinking in such a way that they are kind of uplifted, then I need to be a coach.
Wow.
And so
That's good.
that's my story.
Wow, I like the information about the impact on education, how mathematics has helped you a lot. That's great. So the next question we have here is, in your opinion, why is mathematical thinking more important than just getting the right answer?
So something that I would tell my students often, because they'd be like, well, I got the answer, but and like, I don't see your thinking on the page. And they're like, well, why do I need to show the thinking if I have the answer? And I would tell them, like, the answer is only helping you for this problem right here, right now. The process of getting the answer, that is going to help you get other problems that are similar. And so, like, I really started to value the process of thinking and getting the students to show their thinking. And I really think that thinking is a necessary condition for learning. And really, to me, education is this process of refining the cognitive processes like generative thinking, spatial reasoning, comparing and contrasting, cause and effect, classifying. And so when the students can't do these things in a math task and all they have is the answer, like I know that that's going to limit them in their ability to do math later on in life.
Wow, that's great. It's really amazing. The mathematics thinking has helped a lot. Wow, that's great. The next question we have here is not to waste our time. How can teachers help students develop strong reasoning and problem solving skills?
The short answer is that the teachers need to give thinking tasks. If the task doesn't give the students the opportunity to think, then it's not going to happen. And the other thing is the teacher's going to have to foster the problem-solving skills. And so they're going to have to, as they're consolidating the knowledge and as they're sharing the solutions that the students came up with, they're going to have to give attention and get the students to notice the different ways the problem was solved and how those problems were solved in a similar way, the assumptions that were made by the different groups, and then like what strategies could be used. And sometimes the teacher's going to have to plant seeds with the group and suggest a strategy so that way that group can share it. And so if the teacher isn't giving problems that are worth solving, that have multiple entryways, that have multiple answers, that require reasoning and have a little bit of ambiguity to it, then they're going to have a really hard time teaching that problem solving and that strong reasoning.
That's great. Teacher can help us to develop a strong reasoning and problem solving skill by giving us a lot of question and there is a way they teach that will make the maths easy. That's great. So the next question we have here is, what are some common mistakes teachers make when teaching mathematics?
So one of the things that teachers can really fall into a trap of is trying to rescue a student. And I see this with the teachers that I coach. There's this uneasiness of when a student is struggling and they want to step in and give the answer because that's going to relieve the distress that student's in the moment. But I'm constantly reminding the teachers that there's this idea of productive struggle. Another way that it's said is desirable difficulty. And so when you allow a student to kind of have that slight discomfort, you don't want it to be where it shuts the student down, but you want it to be where it causes some sort of need to do more than what they thought they were capable of. And I kind of always equate it to like lifting weights. Like if you're always lifting a weight that isn't a struggle, you're not going to get very much stronger. You might build more endurance, but you're not going to get much stronger. And so, building strength, whether it's in the mind or the body, it requires some sort of challenge to do more than what you could before. And so when a student is in that space of struggling, they have to start retrieving information. And cognitive science really talks about how retrieval practice is a very strong thing that helps students remember what they have been taught and helps them to kind of organize their thoughts. And so by giving them a little bit of a struggle, you start to get them to retrieve on their own, and that's reinforcing the learning. They're also making connections with their prior learning, and so they're kind of having to sort through, like, what have I seen before that's similar? how can I use what I've known before in this problem? And that really helps in the schema formation, and is going to make the learning experience last longer for the student.
Wow. So teacher helping us to rescue, like giving us a difficult question, giving us something we can relate it with life, right?
Yes.
That's great. Thank you for that so much. I really like the idea. So the next question we have here is, how can mathematics be connect to everyday's life to make learning more meaningful?
So I like to say that math is life, and I kind of really think that math is everywhere, but that's not really a satisfying answer. And it's kind of like one of those things, if you want to know what water's like, don't ask a fish, because it's surrounded by it. It's not going to give you a very good description. And sometimes I think as math teachers, when we ask, like, where can math be connected to the real world? Like, we want to say it's just everywhere, like, just pick anything. But when you ask a student, like, what they hate about, like, real world problems, is that none of them really seem real world. You know, who goes to the store and buys an unreal amount of fruit, or, you know, who's calculating trains traveling opposite directions and meeting sometime in the future. Like, we don't do those sort of things. So what I've tried to do is just really think about the things that the students care about, and then also, how could I use storytelling to set up the problem? And, you know, one of my goals is that the story starts to get their mind thinking, because you can pause at any part of the story and start asking, well, what kind of mathematical questions might we be able to ask here? And before you even ask a question, you can kind of see where their mind is at and what you might need to talk about before you get them started. And then if you get really good at it, you can use a story where the solution to the story requires the math that you're asking them to do. Because then when they solve the problem, it's resolving the tension for them. And so, like, that math becomes part of that story, and they're wanting to do it, because when we hear a story and we don't hear the ending, like, it bugs our mind and we want to know what that ending is. And so when the math becomes part of that story and part of the ending, then it keeps them motivated into doing the math. And so, like, I first started off with, I would love stories of that were like on a video that weren't very long, and just, all right, well, what's happening here? What are you noticing? And then I would have something like, I had goats just eating grass, and I was like, my goats are really hungry, but, like, I need a fence around them, but I only have so much fence. And so, you know, how can I maximize the amount of space that the goats can have to eat with this amount of fence? And so now they're having to explore the relationship between area and perimeter. And so, you know, that I'm pulling them into the story a little bit, and the students weren't quite impressed with the goats, but I would find sporting events and like, okay, we're seeing someone throwing a discus, and, you know, how could we measure that? And so that brought into the conversation things like positive, negative numbers.
Yes, that's great. Like, to make maths connect with everyday's life, just to use a storytelling for them and what they can relate with mathematics and the topic they are doing. That's great. Thank you for that. Thank you so much. So the next question we have here is, You work with teachers across different subjects. How can mathematical thinking improve learning beyond the math classroom?
So I kind of view that like all of math thinking is the same thinking that's happening in other classes. When I kind of think of the Greek word that we get the word mathematics from, it means learning. And so if you're engaged in any learning, you're doing mathematical thinking. I think sometimes there's a confusion about what math is, and we tend to focus on just the computation part where we're adding, subtracting, multiplying, dividing. And like that is part of math, but there's so much more. There's measurement, there's spatial reasoning, there's noticing patterns, using the patterns, using the structure of our number system. And so like these problems open up all sorts of thinking. And because I've taught all the subjects, like I really did see the same sort of thinking in the other subjects as I was teaching the mathematics, and I would try to bring that to light with the students. And so one example is compression. Like when we are using exponents, we are taking a whole lot of information and we're compressing it into a notation that doesn't take very much space. But we do the same thing in language when we have contractions. Instead of saying cannot, we say can't. When we have a long word, we abbreviate down to just some initials. And like this goes back all the way to Latin in the Middle Ages, where they would use initials like EG or example gratis. And so like the human mind, we like to condense our information, and this is something that we do in math, and it's also something that we do in ELA. And when we are telling history, we don't tell every single event that happened, we tell the highlights of it. Then when you do a scientific investigation, you're given a summary of the stuff that you did. And so like the different ways of thinking that we engage in, whether it's comparing, contrasting, classifying, looking at cause and effect, we see those in all the subjects.
Wow. The easy way to how can mathematical thinking improve learning beyond the math classroom by using the companion. Like that's really great. Thank you for that. Thank you. So the next question we have here is, what strategy have you found most effective in building student confidence in mathematics?
So I don't know how it is elsewhere, but in the United States right now, the students, especially in the middle school, which is where I've worked, the kids come in almost defeated. Like they look like they've been beat up by math. And so I noticed the first year that I taught, as soon as class would start, 10 hands would go up. I need to go to the restroom. I need to do this. And like they're trying to escape. And like it's clearly the fight or flight mechanism happening. And so like I started to look into like what's causing that, and then what can we do about it. And a lot of the conversation around math anxiety and math trauma starts to focus on belonging, and not just welcoming the student and be like, hey, I'm glad you're here, but welcoming their thoughts, and then setting up a classroom culture where mistakes aren't laughed at, and where mistakes are valued and add value to the classroom discussion of the mathematics. And it takes time to build that culture up. And I was just reading an article today that was talking about the importance of the first couple weeks of school, and that's the time that you set up, this is how we're going to do math in this class. And it takes doing non-curricular tasks that allow you to focus on the behaviors that you want to see. And then as you're doing that, like you need to establish the ability for the students to work together, because as they're working together, then they can start to see that they're not the only one that has that feeling. Because when they feel isolated and they feel like they're alone in their feeling, then it perpetuates. But when they see that they're not alone and they see that others have gotten past it, then they too start to get past it. And it also allows you to publicly ask a student, like, hey, I just heard you share an idea with your group. Would you mind sharing it with the whole class? Because that idea is very important. And so when you start telling them, like, hey, this is an important idea and the rest of the class needs to hear it, then that's starting to build their confidence. And so they need to have these moments of success and start collecting evidence that their ideas matter in the class and that they have ideas that are contributing to the mathematical discussion on a regular basis. And that's the type of belonging that truly matters. You know, I've been calling it academic belonging. Some call it agency. But it's when a student is able to see that not only do they belong socially, but they also belong cognitively in the classroom, and that their ideas are being asked for and shared and valued, then they start building confidence.
Wow, that's great. That's great. I like the strategy. It's very unique. So the next question we have here is, how can school create a classroom culture where students enjoy thinking, asking questions, and solving problems?
So, the classroom culture, again, it starts in those first few days of school, and it's not something that you can just put on a poster and put on the wall and then hope that it happens. It's one of those things that you need to create opportunities for it to happen. You need to teach the kids the skills for the culture to happen. You need to remind the kids of the norms, and then when the norms aren't happening, you need a way to address it. I really like single point rubrics where you tell the students, like, today we're focusing on collaborating. We're going to move from turn taking to collaborating. Maybe the students are struggling on persevering in the task, and so we're going to move from giving up on the task to staying in the task. Maybe the students are struggling on talking respectfully to each other in the group. And so, you know, you start working on, we're going to move from just being short in our words to making sure that we disagree with ideas and not people.
Yes.
And you have to disrupt the behavior, and so you have to give the behavior time to surface, and then you need to disrupt it when it's happening. And then that's how that behavior changes, and that's kind of how culture sets. And so, you know, culture is really a system of values and beliefs and norms that we use to kind of make sense of the world around us, and it's kind of how we function in class. And so you need the behaviors, you need the norms, you need the beliefs that we are responsible for each other and we're responsible for our learning. We are responsible to engage. And you do that with tasks that don't always have a straightforward answer, where the kids aren't going to know the solution right away. And so that's going to give them the opportunity to start to think, and that builds curiosity, and curiosity creates joy. And so when you create that space where there's a little bit of ambiguity, then questions start to arise. And ambiguity is a problem to solve. And so you want to have that ambiguity where they are trying to resolve it and try to come up with an answer. And so debate is a very strong way of bringing that into the classroom where they will enjoy the thinking because they get attached to their positions, and they have fun when they are exchanging ideas and going back and forth. There's this idea of structured academic controversy where you can take something that is mathematical and controversial and get them to debate about it. Things like who's the best in name whatever sport, and you can curate the statistics so that way maybe if they're just looking at who has the best score, they're maybe not looking at the whole picture, but if they're looking at just the mean, maybe they're not looking at the whole thing. And you get them to start considering the spread of the data. If you pick people that they know, then you can remove the names and you get them to debate as to which player is better based on the statistics. And that gives them the need to know the different things in statistics, like the center of measure and the measure of spread. And then you reveal the names, and then they keep debating about it even after class.
Yes, thank you so much for that. About the culture, how well students can get thinking, asking questions and solving the problem. That answer is a unique one. I really love how you put the explanation. Thank you for that. So the next question we have here is, what advice will you give to new mathematics teacher who want to make a lasting impact on their students?
I think for the new teachers to make a lasting impact, it starts with the belonging that I was talking about. If a student can't see themselves in the math, they can't see themselves in the examples that you use, if they can't see how it relates to their life, they're not going to feel a change in who they are and how they see themselves as a person who does math. And so to really have that impact on students, it really takes having a commitment to creating a classroom culture where they know that they're valued and that they have success in a meaningful way, that they see themselves as someone who can competently do mathematics.
That's great. Thank you for that. Thank you for the advice. The lasting impact on their children is depending on how they handle it. That's great. The next question we have here is, what message would you like to share with educators, students, parents about mathematics?
I would
mathematics education.
Like to throw out the idea that, math is something that is deeply human, and it is something that my thought is that math anxiety and math trauma wouldn't be as much of a thing if mathematics wasn't deeply connected to being human. And because I don't see in ELA people saying like I have ELA trauma the same way they say they have math trauma. And I think part of that is that math is, of all the subjects, uniquely just part of being human. And even though we may not articulate that when we do not feel like we have been successful in math in a math class, like we almost take that as an attack on our humanity and start to shut down and start to feel a certain way that we don't in the other subjects. And so if we remember that kids come into the world with intuition in mathematics, and if you read some of the cognitive science, it talks to how we have a number sense from birth, and it's our number system that is new and that has to be taught. But our ability to estimate or systematize numbers We can do that at a very young age, and then we can combine numbers. And so when you start giving kids manipulative and concrete objects, I have seen videos of kids who are 5 years old do division problems with fair sharing, because they're like, hey, I've got this many objects and it's going to share with these many people. And the kids know, like, hey, if I'm sharing, then I'm giving one here and one there, and they're able to come up with it. And a lot of times, if as educators, we can just get out of the way of the kids thinking, like, they can do a lot more than what we think they can. I was in a session at a conference where the speaker had a recording of her grandson in 2nd grade doing a problem, and he was able to solve it no problem. Same kid in 6th grade given the same problem, he had no idea where to start. He's like, well, I think we're supposed to do this. He had all these different rules that we teach. Here in the States, we call them rules that expire. And all these things that were not part of his intuition, he got confused by it and no longer knew what to do. But when he was at a younger age and was able to rely just on his intuition and the objects that were in front of him, he was able to make sense of the problem and actually able to do it. And so when we're teaching mathematics, we kind of need to be aware of what students can do, what their learning trajectory is, and then make sure that we're not adding confusion to that and shutting down the thinking that comes naturally to them. We need to use their thinking.
Yes. Thank you so much for this section. I have my own question that I want to ask. In Nigeria, many believe that when you study math, you are meant to be a teacher solving for X, solving for Y, the S, and a lot of things. I used to tell people that math is beyond that. What is your thoughts that you can just give for other Nigerian students who's going to watch this video?
For the math that's beyond us? Was that the question?
Like, math is beyond the X and Y. They don't believe that math is beyond solving question on paper. Okay,
so math being beyond the equations and the expressions that we use. So my thought is, if we kind of think about how mathematics came to be, we as humans, we start off with counting and marking bones with those counts. And when we started doing that, like, we now started using those marks as a symbol to represent something that we counted physically. And the heart of mathematics is encoding what we understand about the world, in such a way that other people can understand what we have written in symbols. And when you look at where math started getting traction, it was something that was used to solve problems in society. It was something that was used to measure the world around us. And in measuring the world, that became important for crops, because they needed to know when are the crops going to become ripe? When are we going to need to pick them? When do we need to plant them? And do we have enough food to sustain ourselves in between those times? And they took a lot of time of staring at the sky, and they got really accurate at being able to say, this is how long this takes, and this is how much that we need to prepare for this. And so all these equations that eventually came out of it are just a symbolic representation of the measurements and the calculations that we were doing for our survival. And so when we think of math as just this manipulation of numbers and just these equations and finding X and Y and whatnot, we kind of divorced it from the rich history that it's had of how it has been an integral part of our society and how it has helped humans move beyond just hunting and gathering and moving into farming and sharing the farm produce and being able to use machines to do more work and be able to calculate the amount of work needed to do. And like all that is where it started, and then we needed a way to write that down and transmit it so people wouldn't have to relearn it. And so like that's where those equations come from. And when we're practicing those things, we're kind of stepping into a rich history of humanity.
That's great. Thank you so much for this wonderful section, for delivering this. I really appreciate. Thank you so much for accepting our university podcast for it. Thank you so much. I really like the way you give us the knowledge on how mathematics of thinking is helping us beyond struggling classroom through reason and evidence. Thank you so much. So this is the end of this section. Really appreciate you. Thank you. Bye bye.
All right. Bye bye. Thank you.
All right.